So hello everyone, my name is Noman and I'm presenting a work on behalf of our colleagues from the University of Udine, which is a wide slice residual network for food recognition. So in this work the authors present a deep neural network approach, and it's designed to capture some structural information that may or may not be present in some images of food. More specifically, this approach here combines a specific and a generic representation. So if you take a quick look at the proposed architecture, in general, it's composed of a left and a right part. So you see this at the left-hand side of the slide. The right part of the image is just your typical residual network. Okay, and this just learns the general representation of the image, where the left part is the wide slice representation. So the idea why here to use basically the residual network is just because the deeper you go with some architectures, you do come across so slow training or the vanishing gradient problem. Again, a more detailed explanation of the architecture here is that some existing approaches do not specifically address this vertical trait structures in images. This is here represented by this lasagna slice, where basically so the first part represents this the normal residual network, where basically you just have a convolutional filter of something size, either 3 by 3, 5 by 5, or something which you want to use, and the second image here down below represents the right part of the architecture, which is basically the wide slice residual. And here the author proposed just to use a filter of the width of the image and the size will appropriate to its slice, as you can see here. So with this, you should be able to capture some structural components of the food. So it was basically evaluated on 3 data sets consisting of 100 to 200 to 256 different classes of images. The model used here is pre-trained on ImageNet, and basically the fine-tuning, so the author state it was around 2 to 3 days on a GPU cluster. So if you take a look at the results, here you have 3 tables for the 3 data sets presented, top 1 and top 5 accuracy. So the first, so they're separated by lines. The first top approaches are all non-deep learning based, whereas the second part below the first lines are all deep learning burst approaches. Of course, as we see these days in many fields, the deep learning approaches perform quite better. So perform quite better. Okay. And then the last rows here are just some basically accuracies that you obtain if you don't only consider the ground truth image, or basically the ground truth label of an image. So if you have an image that has maybe 2 or 3 plates, and the first part is just considered the ground truth imitation of the so not the whole image. Some other results here are, for example, so the green bars represent this combined approach. We're using the specific and the generic representation, so the wide slice and the normal ResNet, whereas the blue and the red bars represent using just the normal ResNet. So if you see, so the line where the blue bars end, these are all foods that kind of have this structure, whether it would be a lasagna, a cake, or something, and the red bars basically represent food that has no such structure, such as rice or something like that. So in general, here the performance is improved. Vertical traits for around 2.5% and non-vertical 1.3. The performance is degraded in only 23 classes over the remaining 86 categories which do not have vertical traits. So if we then just quickly take a look at some basically quantitative analysis. So in the first picture you see some scrambled eggs, and here this proposal was basically able to identify this as scrambled eggs. The following 2 images, although it's not very sure that this is rice with some added food, it is quite sure that this is rice. It has an idea that it is rice. And in the image where you see meat, here basically it mislabels these images. But again, in the top 5 rankings, you see that it has an idea that this is meat. And maybe here one thing to note is that that big slice of meat there, the ground truth here notation are the fries behind the meat. So, and then yeah, if you plot then this visual attention, where basically the convolution look for is basically you see that it looks like the food plate. Thank you.